Hello everybody, Bob Giglio again, back in the shop. So today's interesting little video I want to do for you. I just had trouble with my Keurig coffee maker. So let me show it to you. So here it is. It is a K-Express, I think it's called. And it was fine. It was fine. It's about 7 months old, 6 months old. One day I decided that it was time to do a descaling operation, which is this little button here. Down here, and I went through and followed the steps, but something went wrong and it got stuck into the descale mode, and now it doesn't want to work at all. And so I can show you what it. So when you push the power button on like that, it just flashes twice and then shuts down. So I'm not sure what happened. I did get a warranty replacement on it, so let's go ahead and do an autopsy on it and see what we can find out. So going and using my trusty iPhone tools to separate some of these panels. I'm just running it in here. I don't know how this comes apart, so I'm kind of figuring it out, but there are some tabs I'm hearing in there, and look at this. It seems like it's opening up now. I'm just going to do it on this side. And take that right off. Okay. Well, that was not that hard, was it? Okay, with the back off, let's see now if I can take this bottom off. It seems like these side panels are secured with the bottom. Okay, so I took that off. The base basically came off with it. It's just the cover for the water intake, the check valve here. It looks like this base is just snapped in place with some plastic tabs holding in place. So let's see if we can, there we go. There we go. Our thing. So it's always good. Okay, there's the base. Okay, so I did break a few tabs because it was pretty tightly in there, but it's just all in place by plastic tabs on the case. Go against this control board here. Wood might come out now. Okay, so this is the circuit board. It's just held in a couple of tabs. So here's the control board. I don't see anything obviously wrong with it. This is a heat sink here. Maybe this power diode maybe right in here, dissipate the heat. Everything looks to be in order. On the buttons, here is the button pad where the outside buttons interface into these small micro switches that are implanted in the board. So I don't see anything obviously wrong with it. There is some residue here. You can see it maybe from the manufacturing, the soldering process. There is some white residue here. I don't know, maybe they didn't wash all the flux off of it. But you can see this is not a simple device. Look at all the processes. This is probably the main processor here. But there's several other ones here. I have no idea what they do. But they're there for a reason. So this pad with the switches on it just have these tabs here. Sorry, these tabs that come through the board, and I just poked them through, and now this little switch pad comes off, and you can see now here all of the micro switches are here, right here. So so I took the top off, and this was important piece, a way to remove this top, was I figured out that there is a strut here that holds the top section assembly to the main body here of this plastic framework. And I learned the hard way that this piece fits into here with some tabs, so it pops into here and locks in place. So after I broke a couple of tabs trying to get it off, I realized how it snapped in place. And then once I got this piece off, then you could see this piece basically fits into here, and that also came off. So that was important because if you look down here, you won't be able to see too well, but there was a screw down here that I had then removed. And then once I removed the screw, now I have separated this, or disconnected the strut from the main body to the top. And now, okay, now with that rear strut disengaged, it seems like this will just snap out from the top like that. So to have these two plastic pins fit into here. So now the top has been removed. Now we're just going to go ahead and disconnect some of this tubing so we can separate. I removed the head from the body, as you can see here. So, and I'm exposing now the tubing. I had to disconnect some of the tubing so I could do this, clearly show you what I'm seeing. So that's the head that's been disengaged now. So the body's here. And let's point out some of the functionality of this and the equipment in here. So as I said before, down here, down here is the heater element, the water heater, and you see the spiral tubes that wrap around it. The core is a electric heater, resistant heating element in the middle of it. You can see here, this is the thermostat right here that knows when to turn it on and off because it comes from the power line. The red is power to the cord here, as you can see right here. So this is basically a switch that will turn off the right here. That will turn. Maybe it's a safety, but it looks like definitely a thermocouple is against the body here. So if it gets too hot, it turns it off. Here is the element, the power going into the element here on the positive side, and the water inlet here. This is the hot water. Actually, this is the hot water outlet that goes to the needle in the pod. And then on the bottom of it, you see this is the inlet. This is the inlet tube coming in, cold water inlet tube after the pump. And this is the bottom, this is the neutral wire for the heater element. So that's basically what we're seeing. And in here, here are the sensors. So right here are the sensors that sense low water. One is probably for low water. I'm not sure what the other one is for. So you see both sensors here. This comes from the line. This is the line that comes directly from this poppet valve where the water reservoir sits into, the nozzle reservoir sits into this valve. So that's what we figured out so far. Here is the pump. So right here is the water pump. Sorry, right here. So you can see it here. And so it looks like we have a screw here to hold the pump in place, but also we have two screws here, one under this tab here and the other one over here. So we're going to find out how to remove this skirt here, plastic skirt, to get at those two screws, and then I'm going to remove the screw for the pump and see if we can see where these nozzles go and disassemble this head. So I removed the pump right here with one screw. It was just like that. I just removed this one screw, took the pump out. Then I noticed that this skirt here was held in place with these two locking latches. So I just popped those up, and then this slid right out like that. So now I can get better access to what's going on. I see a couple of screws here like we showed you. Here is this air pump, the vacuum pump here that probably evacuates this line of air. So let's go ahead and remove these two screws here and see what happens. Okay, it looks like those two screws held in this assembly here, and there you go, and there you go. So now we can see that this hot water line goes into, looks like maybe a check valve or another sensor here, and then that eventually goes into this needle right here that actually pierces the pod, I would think. We'll verify that. And this other line is like we thought, a vent line. Here it is right here. You can see it's a vent line here. It just comes up here and ends. So that is just another vent, like we showed in our drawing. So just pull that out. So now we're going to just go ahead and take off this bottom one here. Take off this assembly with these two screws. See where that goes. So yeah, so now how does that, okay, so that goes into here. Oh, okay, and then this comes down like, there it goes. And then you see here, right here, it goes into here, and there's a little filter screen in there, and then goes into the head, and then it probably comes out here. So that's how the water gets up there, hot. And there's a little micro switch here. This is the micro switch that tells the coffee maker to start the brewing process. When you open and close the lid, it depresses this micro switch here, which is way back here, and that's how it starts the logic to do a brew. Okay, and this is the brew cup here, which comes right out like that. So, and that's an anatomy of a coffee maker. It's helpful now to draw out what we just saw and understood. And we did do some more investigations into what these individual components do, but this is the result of what I've determined based on everything that you just saw and I just saw together. So we start here with that poppet valve here underneath the water reservoir. And there's a tube that goes up through here, like you saw. And in that tube are two sensors, sensor 1 and 2. Not sure what these sensors are. It may be just to sense that there's water in this line, and when maybe not to brew because we run out of water. So I'm guessing that's what's going on with these two sensors. And then what happens after them is there's a T in the line, and that T's, one part of the T goes to the water pump that we just saw. Another part goes to what I first thought was an air pump, but it turned out to be a solenoid valve that would open and close according to an electrical voltage going to it. And then from that valve, it goes into a vent, just a vent tube. So that's that's before the pump. After the pump, now the pump comes up here. It goes through this line, which has the pressure relief valve on it, just in case things get too high pressure. It's a safety valve that has a vent in it that goes up to the top of the brewer under the lid. And then the inlet to the heater, the water heater here, comes from the bottom. And then it goes through the heater and then up through the lid and then back down through the needle in the lid, which pisses the pod to send the hot water into the pod and to brew the coffee. So if you look at the schematic, you can understand how this thing works. So when the control board gets commanded to make a cup of coffee, what it does is it activates the pump, and it keeps this valve closed by energizing it. When it's energized, it's closed. And what happens is then the water gets drawn up into the pump. It goes through this line, through the heater, gets heated, very hot temperature, and then up through the lid. And then near the end of the cycle, what happens is this valve here then gets de-energized. And when it's de-energized, it then lets the air, it opens up and lets the air in, preventing the air from the water from being drawn up this way. The air now prevents that from happening. So the air gets drawn to the pump, and then basically it just purges the water. It keeps on pumping until all the water purges out through the heating system. And that's why at the end of the brew, you'll hear that hissing sound. That's what's happening. So you're just basically just purging out the remaining water, and then eventually you're seeing some steam come out. So now it's ready for the next cycle. When you do the cycle again, this valve is closed. The pump draws water from the reservoir, and it goes through the same process over and over again. So the first thing we're going to check, I think, is the most obvious thing that usually goes wrong is the heater. So we're going to check to see if the heater element has the right resistance to it, and that would tell us whether it's working okay. and whether the thermostat is okay as well. Those are the two first things we're going to do, and then I'm going to go progressively and check the pumps and the sensors. So to figure out how many ohms, to check the heater, I need to do a resistance check on it, the element, electrical element. And to figure out how many ohms, I went back and just did some simple power math. And since it is a heater, it is going to be the full wattage, the 1500 watts, which is labeled right on the heater, as you can see right here, 1500 watts right there. So right there, it's going to tell me the rating. And now that I know the rating of the heater, I can divide by the voltage, which is also printed on the label right here. So dividing those two things out using the power law, and since it's a resistor, it has a power factor of 1, I get about 12.5 amps. So watts divided by volts gives you amps, provided it's a resistant heater, which it is. Otherwise, the amps could be higher depending on the inductance in the circuit. And then going and using Ohm's law, which is the voltage has to equal the current times the resistance. And I just saw for resistance, the 120 volts divided by the 12.5 amps that I calculated gives me about 9.6 ohms. So now we know where about the resistance of the heat element should be. So let's go ahead using my multimeter and check to see where it is. So I have my multimeter set up for resistance, and it's in auto range. So let's see what it is. I'm just gonna take the two electrodes. I'm gonna put it across the heating element where the power and the neutral leads go into, and 10.2. So the heating element is good. So that's not the problem. Let's check now to see if the thermostat or the safety thermal switch, I'm not sure which, this one right here, as you can see right in there. We're going to just put the contacts or the leads across that to see if it's closed. And it should be because it's cold. Yes, and we see 0.5 ohms there, 0.3 ohms, so it is closed. So the heating element functionality checked out electrically. Okay, and since there's no leaks, the only other thing that could go wrong with the heating element, this is a good heating element. So now for this pump here, this is the liquid water pump. I just so happen to have a 12-volt battery from my motorcycle trailer here. I'm going to just use this because the rating on this says 12 volts DC. Okay, so here's the pump. I have it hooked up, lead off to my battery. So let's see if it works. And all I'm going to do is get the negative on the black, the red here. It does work. It works fine. I feel the pressure. So I don't think it's that. So right now we have the heater element checked out. The water pump is checked out. Let's see what else we got. Okay. I am getting on my ohm meter, as you see over here, about 125 ohms. So that seems to be about right. But I thought that this was a pump, an air pump, but it turned out to be a solenoid valve. My battery, and I just hooked it up, and so I determined it works because when I connect the battery to it, you can hear it click, number one, and I check the functionality is when it's engaged, when it's energized, you try to blow through this, and you got no flow at all. When it's de-energized, you try to blow through it. You can't blow forward, but you can suck from it. So this is definitely a solenoid valve. It's a check valve, really. That when it's energized, it's fully closed, and when it's de-energized, it allows the air to go in from the back side of it into the system. So now I'm going to check the thermocouple that was in this line here that went right up to the coffee nozzle. Remember this rubber kind of check valve here that went into the lid, and this is where the hot water leaves the heater and it comes through this passage with a little T here, which I'm assuming we just measure the water temperature and send a signal back to the processor that everything's okay. So what I did was I just hooked it up to my test leads here. I put the voltmeter on DC volts, and if it works after it heats up, it should give me a signal, a voltage. It's not giving me any voltage. The other thing I can do is check the continuity to see if it could be a resistive type sensor. So let's put it on resistance, and let's see if the resistance changes with temperature. So that's the other way it could work. So it's reading 42,000 ohms. Let's see what happens when I heat it up, if it changes. Oh yeah, look at that. It's going right down. So it seems to be okay. This must be some sort of temperature sensor. It's going right down to about 9.8, 9.4. Now I'm going to take it out, let it cool off, and look at that, it jumped right up. So it does seem to be working. It's a resistive type sensor, not a thermocouple. So that seems to check out. I also checked out this micro switch that was in the lid. We can open and close the lid with continuity, and that checked out fine as well. So now on to this sensor here that was in, this was in the inlet line. This is one of the sensors that were in the inlet line. So again, I'm 53, 55, 57,000 ohms. I'm going to dip it into some water, see if that changes. Yes, look at that, it goes right down. So it seems like that's okay. This is, let's see, we put them both in the water. Yep, there we go. Again, it's changing. So I think these sensors are working okay. Well, since we've checked everything out and we found that really all the components of the brewer, of the Keurig brewer, were functioning fine. We didn't see anything wrong with them. The finger points to the motherboard or the control board. And since that was the one area that we couldn't check out, and that's the one that has the direct relationship with us pushing the buttons and it responding, since it didn't respond, it was, to me, that was the problem. So I hope you found this video helpful and useful. At least we figured out how Keurig designs their brewers, and they're rather simple, which is, thank God, except for the control board, which has a lot of processes in it and has a lot of logic in it. So anyways, thanks for watching, and see you in the next video.